Here's part 2 of day 13 of Advent of Code. We get to ignore the first line of the input and just focus on the second line for this part. So consider each of these bus IDs. So 7 is at the 0th position, 13 is at the 1st position, or you can think of it as offset by 1. We ignore these two, so that's 2, 3, 59 is at an offset of 4. Skip this one. This is at an offset of 6 and an offset of 7. So considering these bus IDs and their offsets, what we want to do is find a timestamp where the 7 bus arrives exactly at that timestamp. And then each bus after that arrives offset from that timestamp by its sort of ordinal position in the list. So the 13 being offset by 1 should arrive 1 tick after the bus that our original timestamp. Similarly with 19, which is offset by 7, it should arrive 7 ticks after the timestamp that we're looking for. 1, 2, 3, 4, 5, 6, 7. See that? So yeah, we can see even with this small set of inputs right here, we get up to a pretty large number. They give us a couple other examples down here and then warn us that the timestamp we're going to end up with the main input is going to be larger than this, so a rather large number. I've done a little looking into this, and you'll notice an interesting property about all the input we're given, and that's that all of these numbers are primes. So there's some intense, to me, number theory, something about the, what was it? The, it just flew out of my head. Let me see. The Chinese Remainder Theorem. Now, I've tried to look at this a little bit, and at least right now, I can't seem to penetrate it. So instead, I'm going to do my best to brute force this. Even though it's a large number, I'm hoping that I can push through to an answer. But first, we'll see if we can arrive at this answer right here. So we'll jump over here and we'll save our part 1 solution as part 2. We're going to ditch most of this, I think. And I'm going to jump back to using the sample input for now. And then, yeah, let's see. How did I handle splitting out the bus listings? I think maybe I deleted too much. Here, I need that. So let's switch this to sample now because I want the buses in service. And so I guess before we filter out the X's, I want to have an idea of what the indexes of each of these are. So what if I were to say with index, then filter over the value and the index. And so if it's X, we'll ignore it. And then in our map, we'll have to, again, take value in I. And maybe we'll create a struct for this where we take the value and the offset, or the value or cycle. I don't know, that's the time the bus takes. Timing, something like that. So we'll map over this and create a bus for each of these, where for the value we call to I, and then for the offset we just give it that index. So that's a lot there. I'm going to put it on new lines to make it a little easier to read through. Okay. So the way I'm thinking about brute forcing this is if we're given, let me see some numbers we can work with here. So if we're given this, then any multiple of 7 is going to be divisible by 7 with a remainder of 0. In this we want a remainder of 1, or we want it to be like offset by 1. 2, 3, and then here's 4, 5, 6, and then 7. So anything that's a multiple of 7 is going to be good. And then once we've found that, we want to search for something that is we want to search for a number where that number plus 1 is mod 13 equals 0. And if we can find and we would find that number by kind of incrementing by 7 at a time until we find one, because we always want to be looking for a multiple of 7. So then once we find that x, that's like sort of a checkpoint of our timestamp, and then we continue with looking for multiples of 7 times 13, because we want to sort of hang on to numbers that are going to be divisible by both of these. And so then we look for a new x where it is plus 4, and the mod of 59 would equal 0. And we keep doing multiples of 7 and 13, incrementing that until we find one that satisfies this line, and that's our sort of new checkpoint timestamp, and then so on and so forth. So we'll have our timestamp. We'll say it starts at 0. And then these multiples I'm talking about is, there's like a mathematical term for it, which is the least common multiple. That's how we find the smallest number, which will be our answer. So we will say that our least common multiple starts as buses in service 0 dot timing. Yep. And then for bus listing. Oops. Buses in service, sorry. And then buses in service dot dot last. I wonder if we do a range. I don't know. We'll say dot last bus in service dot size -1. I think. Just test that real quick. So list dot last with dot size -1, and does that exclude the first thing in the list? It does. Okay. Because we already handled the 0, so then we just want to iterate over everything else. And so we will say, essentially we want to check if bus dot if timestamp plus bus dot offset, if that modulo bus dot timing does not equal to 0. Yeah, this is almost like a while. So while this condition of it not being equal to 0, while we haven't found something that matches this condition here, then we will increment the timestamp by the least common multiple. And then eventually we will have satisfied this condition, at which point we want to increase our least common multiple to be like LCM gets the current LCM times our current bus timing. So if it was 7 before that we're incrementing it by, well, it should now be 7 times 13. I guess it's saying we can use a shorthand here. So yeah, I think this is sort of vaguely in the range of what we're looking for. A couple concerns I have are making sure that this with index filter map, all of that works. So I'm going to pry here just to check that. And then let's give it a chance to run this whole thing. We'll just want to put the timestamp. So let's see Ruby part 2 and see how we do. With index for array, that's fine. We have to say .h with index, I believe. Okay. So then how are our buses in service looking? Yeah, that all seems right. Cool. And then 1068.78.1, 1068.78.8. Seems like I'm off by 7. So I'm wondering if I didn't start the timestamp at the right place. Just for kicks though, I wonder if this were 7. If we were to run that again. I get rid of this pry. Yeah. Well, what if we were to leave that back at 0 and just go through all the buses? Would that make any difference? Right, no, that's too big of a number. We already handled 7 on its own. Or at least common multiple was 1, and we did it over all of them. Yeah, we're still off by 7 there. Oh, I've been looking at the wrong number this whole time. Okay. Well, that was unfortunate. Let's jump up here then and give this a try with our input then. Expect this to run for a little while. Oh, that was rather quick because computers are fast. So let's plug that in. And all right, we got our second gold star for the day. Cool. I feel like I wish I could have figured out the mathy or number theory approach, but brute forcing it seemed to do the job considering the size of the input. Anyway, thanks for watching.